Okay. Now we will start with engineering geology, weathering, weathering of rocks, types of weathering, impact of weathering on engineering construction, and if time permits, we will see soil also. Rock weathering. What do you mean by rock weathering? So we know the rock is a geological formation. This will be disintegrated. This will be broken into smaller pieces that we can call as a weathering. Weathering is a process that changes solid rock into sediments. With weathering, rock is disintegrated into smaller pieces. This disintegration is due to mechanical weathering and chemical weathering. The most aspect of this process is that the weather product remains lying over and above or near to the parent rock unless it is removed from there by some other agency. Here, what do you mean by some other agency? It can be wind or water. So this paragraph, you can clearly understand using this figure. Here you can see this is a massive rock. This got disintegrated. That is due to the process of weathering. The weathering, what are the main reason for weathering? Again, wind, temperature, humidity, all atmospheric rainfall. Because of all these things, weathering is happening. This got disintegrated and it is in place. Or sometimes it is falling nearby and it can be taken away from this place due to water or wind. That is what given here. Once these sediments are separated from the rock, erosion is the process that moves the sediments away from its original position. So, this is rock weathering. This is example of columnar basalt. Now let us see two types of weathering. How the massive rock is getting disintegrated, smaller pieces. Two processes are main reason for that. One is mechanical weathering, other one is chemical weathering. Now let us understand the mechanical weathering. Disintegration of rocks into smaller fragments without a change in their chemical composition. Big size into irregular smaller fragments. What is the meaning like without change in their chemical composition? Just rock is getting broken. Even after broken, it will have the characteristics of the big rock from which it is broken. That is the properties of mechanical uh, weathering. The rock which are weathered by mechanical process. Sometimes what happens, if the surface is plain, these loose fragments rest on it. So you can see here, just one over the other, it is resting. If it is a slope, the fragments roll down under the influence of gravity and get accumulated at the base. All fragments will have same chemical composition as that of parent rock. Temperature and organic activities are main reason for mechanical weathering. Temperature variation, how this mechanical weathering is happening due to frost action in cold regions, thermal effects, insulation in hot arid regions, and unloading. These are the three major reasons for mechanical weathering. Now let us see frost action. Now, before reading this, just see this figure. We have a rocks and it is having fractures. During rainfall or runoff, the water is filling these fractures. Okay, this is what we are going to see now, frost effect. Now, during cold region, this water is becoming a ice. Okay, Then this ice is getting frozen and it is exerting pressure, it may expand. Now we will see that detail. Water on freezing increases its volume by 10%. When it is increases in its volume, this expansion exerts 140 kg per centimeter pressure on the container. So if you see here, this side and this side, for per centimeter 140 kg pressure is exerted from this ice to the container. Here the container, inside the container is rock. In intensive cold region, water freezes in pond and lake, that we know. The process of freezing of water is also happening within the pores. As like how it is getting frozen in the pond and lake, the water which got into the fractures is also getting frozen. Um, it can be pores, cracks, fractures, or cavities. Due to this, the original openings are widened at first stage of attack and thereby accommodate more water to come and freeze in subsequent cycle. So first time water goes, volume increases, pressure is exerted, slightly the crack widened. Then during summer season, it will become water, it will go away from it. As it is widened, next cycle, it is holding more water than the previous time. Again, the pressure which is going to exerted by this ice will be higher than the previous year. Slowly, the disintegration will take place because of the frost action. By this way, the rock will be disintegrated from the major, maybe these are the parent rock. Slowly, this area will be disintegrated. Now, let us understand exudation. In this process in rock refers to the natural oozing out of mineral rich liquids. You can see minerals coming out. Mineral rich liquids are organic substances from rock fissures and pore spaces. This may be due to pressure or temperature. Slowly, when the content within the rock, when it comes out, it may make some hollow spaces within that rock. Slowly, again, when there is a pressure, that rock may disintegrate away from the parent rock. One more example for this exudation is salt weathering. So, what is salt weathering? Near the seashore, let us assume, salt water seeps into the pores and cracks of the rock. When this water evaporates, whenever water is evaporating, the salts will be retained back, only the water molecules will be getting evaporated. First time when the water is evaporated, it will leave some salts on top of the rock. Okay, salt crystals will be there. When this happens as a cycle, um, evaporating, then water is filling, evaporating, water is filling. Slowly the salt deposition will be very high. So the salt crystals may grow or expand due to temperature changes. This aggressively widening the cracks and causing the rock to disintegrate. So this is another kind of weathering. What we are studying now, weathering, how the rocks are getting disintegrated from the parent rock. Now, thermal effects, that means insolation. In arid, desert, and semi-arid regions, maybe in India, this can be Rajasthan or Saudi Arabia, in those area, summer and winter temperature differ considerably, causing rocks to disintegrate. How? Because whenever there is huge temperature change, rocks expand on heating and contract on cooling. This expansion and contraction makes rock weaker and it is getting disintegrated. So what kind of temperature variation? In some places, the summer temperature may go up to 70 to 80 degrees Celsius, and in winter, it is 0 to 100 or even less than 0 to 10 degrees Celsius or less than that. Such repeated variation in temperature experienced by rocks gradually break into smaller pieces, especially in top layers, by the development of tensile stresses. Now, let us see another mechanical weathering process, exfoliation. When rock is layered, the upper layer get mostly affected by temperature. As a result, the upper portion peel off from the underlying rock. Sometimes this is also accompanied by chemical weathering, especially at margins and boundaries of separated layers, developing curved surface. This phenomena of peeling off of the curved shells from the rocks under the influence of thermal effects in association with the chemical weathering is termed as exfoliation. You can see especially the curved surface of the rock where it is highly exposed. Okay, that is what given here. Sometime weathering especially at margins and boundaries of separated layers. Then next thing is unloading. Unloading is one kind of mechanical weathering. Now let us see, before going to unloading, you assume this as a surface. This is the surface. Above this surface, we have a massive rock is present above this surface. Okay, now let us see the theory part. Unloading is the removal of great weight of rock or ice that lie on the surface. So you can assume this is the surface and great loading. These are the great loading which are present. The lower rock, see, when that great load is removed, high pressure is released. The lower rock expands as the pressure falls and fracture occur along the lines of weakness close to the surface. These fractures called joints. These can run parallel or straightly curved to the surface of the land and loosen sheets of rock whose thickness varies up to 10 of meters. On a large scale, these can resemble onion layers and are called exfoliation joints. So big load is removed and suddenly whenever the load is removed, the pressure is released. Because of that, there can be expansion. This expansion may weaken the rock. So the weathering can occur. Disintegration can occur because of that. Now, let us see chemical weathering. Chemical weathering is a process of chemical reaction between the surfaces of the rock and the atmospheric gases and even with the water. Reaction between the surfaces of the rock and the atmospheric gases and the water. Even you need to add water also. So what are the atmospheric gases? Carbon dioxide, nitrogen, hydrogen, and oxygen. The end product of chemical weathering has a different chemical composition and poorer physical constitution as compared to the parent rock. So maybe you may have a big rocks that may be disintegrated, but the disintegrated part, this may not have the same characteristics of that of the bottom rock from where it is broken down. In case of chemical weathering, the chemical properties, chemical composition of parent rock and disintegrated rock is not same. So what are the main processes of chemical weathering? Let us see. Even this chemical weathering is a reason for the colors in the rock, or sometimes caves are formed. For all those things, this chemical weathering is the main reason. But for everything, it may take million years. So main processes of chemical weathering may include solution, hydration, hydrolysis, oxidation and reduction, carbonation, base exchange formation of colloids. Let us see what all those chemical reactions with the water. So solution. From the name itself, something is going to be a solvent with the water. Because of that, the rock may disintegrate. So let us see now. Some rocks contain one or more minerals because rock integrated more minerals in it. Okay. Few minerals, one or more minerals that are soluble in water to some extent. For example, the mineral rock salt and calcite. When water is having contact with those minerals, it will be dissolved in water, and during runoff or rainfall, these minerals will run along with the water. So in those places, there will be small cavities or improved pores will be there. Whereas if you consider the pure water, it is not a good solvent. It will not immediately take out the minerals from the rock. But when it is a carbonated water, its solvent action is enhanced. If the carbon ions are more in water, when that water is in contact with the rock, it will immediately dissolve some of the minerals present in the major rock. So, limestone cannot be easily soluble in pure water, but carbonated water dissolves limestone very easily. Limestone gets porous due to chemical weathering. You can see here, this is limestone. This is a limestone. Wherever you see cavity, because of the carbonated water dissolving the minerals present in this limestone, you can see cavities within that. Slowly, this may disintegrate because there is no stability within this limestone. Slowly, this is getting eroded and it may disintegrate. Then, the next process of chemical weathering is hydration and hydrolysis. Again, here also with water. Some rock may absorb water, but it will not react. There won't be any reaction. Sometimes the water will react with the minerals of the rock. So that only we are going to see now what is hydration and hydrolysis. Direct impact of atmospheric moisture on the rock minerals, as well as the soil or the moisture in the soil, which ultimately affects the structural makeup of the rocks. In general, the inner part of the rock minerals are in stable equilibrium, but the surface crystals are not the same. When polarized water molecules come in contact with such crystal, they form two reactions. One is hydration, other one is hydrolysis. Now let us see the first action, hydration. The ions means the ions in the rock. The ions tend to hold the polarized side of water molecule and form a hydrate. This process of addition of water molecule with rock is termed as hydration. It only absorbs. Okay. So for example, anhydrite minerals absorbs water molecules and forms gypsum by hydration. That's all. Where as it is with contact, it is just forming a gypsum minerals where huge volume will be um, incorporated, because of which rock may slowly get disintegrated. The second reaction is when this water is in contact, ions may be exchanged between rocks and water, and entirely new composition is formed. This process is called hydrolysis. It is very common practice in silicate mineral. Now let us see. So here in the first hydration, there is no chemical change. Okay. Whereas here, completely new composition is formed due to the ion exchange. So whenever this kind of ion exchange is happening, it is losing its original strength. Now let us see another kind of weathering, oxidation and oxygen reduction. It is interaction of oxygen and the rock. Oxygen in the atmosphere and oxygen in the water, or oxygen in the soil and the top layer. Oxidation is the reaction of substance. Substance here is rock. Reaction of minerals with the oxygen. When ion in rocks reacts with atmospheric oxygen or with the oxygen in water, it forms iron oxide, which weakens the rock. Whenever we talk about ion, the color, it will be somewhat rust orange or something. So you can see one example from Shutterstock. Oxidation is the reason for signature red, orange, and brown. If you are seeing any such color in the rock, this may be due to the reaction between the minerals in the rock and the ions, oxygen present in the atmosphere or water. So now you will be able to tell if there is any color change, orange color, you will be able to tell the reaction between the oxygen in the atmosphere and the rock changed this color. So brown coloring seen in many geological formation. Now, oxygen reduction. Just the opposite. The rock is not in contact with the oxygen, direct atmospheric oxygen, or some completely in waterlogged area. In such a case, it is not continuously in contact with the oxygen. In such a case, what will happen? Oxygen reduction. The process of removal of oxygen and is the reverse of oxidation, and is equally important in changing soil color. For example, a ferric ion brown is converted into ferrous to gray. You can see here the brown color is getting converted into blue or gray. So slowly it will happen. Million years it would have been in brown and now it is in blue, because this rock may not have direct contact with the oxygen. That may be the reason for color change here. So, under the condition of excess water or waterlogged condition, less or no oxygen condition, reduction takes place and color change is happening. We already discussed chemical weathering is the major reason for the color change of the rocks or for the presence of caves. Now let us see another chemical weathering, that is nothing but carbonation. So what is carbonation? It is the process of weathering of rocks under the combined action of atmospheric or soil carbon dioxide dissolved in water to form weak carbonic acid. This acid react with the minerals of the rock. Example, when the solid calcium carbonate comes in contact with this acid, it turns into soluble calcium bicarbonate. when it is becoming a soluble calcium bicarbonate, it is easily washed away by groundwater, often forming spectacular caves, caverns, and sinkholes. You can just see here below the ground. Maybe this is your ground, but already carbonated minerals. Soluble calcium carbonate will be there. The groundwater which is passing, that will take this carbonated particles away from it, and slowly it forms a cave. Next type of chemical weathering is colloid formation. The process of hydration, oxidation, and reduction on the rocks often result in splitting of particles into smaller particles. So, what you are seeing now, already we read hydration, oxidation, and reduction on the rocks. So because of that, the particles are converted into smaller particles that we call it as the colloids. These colloids are having atoms with only partially satisfied electrical changes. Formation of colloids are common in weathering of clay minerals. Now let us see impact of weathering on engineering construction. Impact of weathering on engineering construction. Now let us see how this weathering is going to affect the constructions. Okay, now just let us see this figure. There is a road. Here it is actually a road, and this one is a monument. Now, let us see how this physical weathering is going to affect this construction. Physical weathering. So, freeze thaw cycle. So, it is a mechanical weathering. What we studied there, the water is getting in, and during winter, it is getting frozen and exerting the pressure. And then it is again during summer, it is getting cool. I mean, thaw action is happening. And again, the widened gap is again filled. Same thing. Previously, we saw in the rock, but the same weathering, how it is going to affect the construction. Water seeps into the cracks in minerals. Then it is frozen due to temperature. This expands the cracks to widen and potentially leading to structural damage. Then, thermal expansion. Fluctuation in temperature can cause. Previously, these rocks are raw that were present in the nature. For construction purpose also, the same rock we are disintegrating and using it for the construction purpose. Whatever weathering reaction which occurred in the natural rock, even after using in the construction purpose, if it is not properly maintained, the same effect we can see in the structures too. After the construction also, the same effect may be there in the engineering construction. Then, abrasion. Here you can see the face. Because of the abrasion, this got disintegrated. Wind carrying sand and other particle can erode surfaces over time, especially in arid or coastal regions. So now we have seen how physical weathering may affect. These are few examples only. Let us see the impact of chemical weathering on our building. You can see Taj Mahal, which is in India. This figure color, you can see it is in white and this is in slowly getting changed to yellow, but continuous maintenance is required. And here also you can see the building is just getting weakened. Let's see how this processes are happening even after the construction. Now, acid rain. It's a kind of chemical reaction which is happening on the Taj Mahal. This is an example. Sulfur and nitrogen in the acid rain reacts with construction material like limestone and concrete, leading to erosion, color change, and weakening. Here, some color change as example we are showing. Then, oxidation. Oxidation is contact of rock with the oxygen, whether it the water in the atmosphere or water. What will happen? In case the metal, whether it can be rock as well as the metal, such as iron and steel, can oxidize when exposed to oxygen and moisture, reducing their structural integrity. You could have seen maybe in the old buildings, slowly the reinforced steels are getting rusted because of the contact with the oxygen and water. Then hydrolysis. We just studied hydration and hydrolysis. Water can react. Now reaction is happening. Even we studied because of the hydrolysis, complete change in the mineral composition is taking place. So the Great Wall of China. So water can react with minerals in construction material, causing them to break down and weaken. So here let us see Great Wall of China. Certain sections are made from sandstone and limestone have experienced oxidation. What is the meaning? Reaction of oxygen with the limestone and sandstone, leading to surface degradation and weakening of structures. Next one is biological weathering. This we didn't study before, but it is very easy. We can understand directly with the building. Or even if you want to understand maybe in the mountain, you could have seen many times in the mountain, you could have seen trees in the mountain region. What will happen slowly? The roots may penetrate when it is becoming big. The disintegration of rocks are taking place. Even in the building, sometimes small plants are grown where there is moisture as well as more amount of sand is there. Uh, these roots, plant roots, can grow into the cracks in pavements, foundation, and walls, exerting pressure and causing the materials to fracture. So it is, see here, you can see the fracture in this building because of this plant. Then microorganism, lichens, algae and fungi, sometimes on the rock also it may be there, can produce because of these leaves or organic materials in the jungle, everything can produce organic acids on the rock or the building material that deteriorate stone surfaces. So because of the microorganisms also, weathering is taking place. And sometimes, mostly in alluvium or if burrows you could have seen, burrowing animal can destabilize soil around the foundation, leading to subsidence and structural issues. In smaller buildings, these kind of issues can also happen. Now, let us see what are the types of uh, soil and how these soil types are useful for engineering construction. The soils are classified by geological classification and engineering classification. So, how soils are formed? First weathering, then transportation, then deposition. These are the three stages the soils are formed. So after weathering, how the transportation is taking place, this may be by water, wind, ice. So alluvium. If the sediments carried by water and deposited in near water bodies like river bed, we call it as alluvium. A line, sediments carried by wind, deserts and coastal regions. Glacier till, sediments transported by ice. We call it as a glacier till. Then, deposition of weathered material. When the weathered material product carried in suspension, coarser and heavier. So, we have just seen it is getting deposited. That's all. Sometimes it is forming a sedimentary rock, everything is happening. So these are the geological classification. Alluvium, lacustrine, marine soil, A-line, glacial soil. These are geological classification of soil based on how it is transported. You can see here sand dune, desert or coastal deposits. This is by the wind, very fine deposits. Okay, now again, soil, how it is, engineering classification of soil and it's important. So, how they are classified? Very coarse soil, fine soil. Further, very coarse soil is divided into boulder, then gobble size. Greater than 300, 80 to 300, whereas coarse gravel size, sand size. Coarse gravel, fine gravel, coarse sand, medium sand, fine sand, and their sizes are given here. Fine soil is silt size, clay size, silt and clay. Their sizes 0.0022 to 0.07. Clay size is very less, 0.002 mm. So, gravel, sand, silt, and clay are represented by group symbol G, S, M, and C. Physical weathering produces very coarse soil. Physical weathering, frost, thermal effect, all those will come under physical weathering. Uploading, all these are physical weathering, which is the reason for very coarse soil. Whereas chemical weathering is reason for this fine sand. So what are the chemical weathering? Oxidation, hydration, colloids, all these are reason for this fine soil due to the chemical weathering. Now let us see how it looks and practically where it is used. You can see boulders, big boulders, and then gobble size means this one, very coarse soil. Whether this is mechanical weathering or chemical weathering, these are due to mechanical weathering. Then now this gravel itself, you have coarse and fine gravel. You can see how the gravels, rock base, most common types of gravel. Rock base, crushed granite, lava rock, shale, shells, pea gravel. All these are most common types of gravel. Then you have coarse soil, that is sand. Okay, now let us see fine soil. Fine soil, silt, and the finest version is clay. So this is silt you could have seen in real life also. Near the river, you could have seen this kind of silt. Clay, within the silt, sometimes you may have clay also. So, how these boulder, gravel, silt are useful for engineering construction? Let's see this. See this figure first. This is called gabion. This is for foundation. This is for aesthetic look. This is near the to avoid the coastal erosion. Okay, see here. Boulders are used to stabilize slopes and prevent landslide. Along the river banks, boulders are placed to protect against the erosive forces of flowing water, ensuring the stability of the bank and preventing soil loss. So this is what we are seeing along the river or seashore. We have this. Then boulders can be used in the construction of foundation and retaining walls due to their strength and stability. Boulders can be used in the construction of foundation. See here. Here they are keeping it for foundation purpose and retaining wall due to their strength and durability. Then landscaping and aesthetics. See here, just for a beautification also, these boulders are used. Then gabions. Gabions are wire mesh container filled with boulders or stones. This also near the, to avoid the small land subsidence, they keep this kind of gabions. Used for various engineering applications like retaining walls and erosion control and prevent coastal erosion. This is the use of boulders in some of the examples we are showing. Now let us see what is the use of gravel and sand. Gravel is used, you could have seen while traveling or just near our house also, whenever they are going for a construction, whether it is a bitumen road or concrete road, the gravel base layer, gravel is used for road construction. Example, a gravel base layer supports the pavement and ensures even load distribution. Then gravel filled trenches known as French drains are used to redirect surface and groundwater away from the structure. You can see here, this is gravel drain. You assume our house is here. Our house is here. So the groundwater, especially in European countries, the groundwater will be very shallow. We don't want that to get into the foundation. So we have some gravel, gravel drain. When water comes here, it automatically go. There will be a pipe to collect the water. Even during rainy season, the surface water will get into this drain and there will be pipe and below it, that pipe will collect the drained water. So gravel filled trenches known as French drains are used to redirect surface and groundwater away from structures. Concrete used in building foundations, bridges, and highways often contains gravel aggregates for added stability. Without the gravel, there is no concrete. Then, railroad construction project use gravel to maintain track alignment and drainage. Here also you see here, and also for the drainage of water. Gravel serves as basalt under railway tracks, providing stability. So it aligns the track under stability. Now let us see how sand is used. We know, like for civil engineering construction, sand, gravel are major required one. Sand is a vital ingredient in the production of concrete and cement mortar. Mixture of cement and sand water, that is, we call it as a mortar. Concrete slabs, walls, and columns. For everything, sand is required. Highways and airport runways utilize sand in asphalt to withstand heavy traffic loads. Utility trenches for water and sewer lines are often backfilled with sand to ensure stability and prevent settling. You can see here sand. It is a pipelines just for the stability purpose. Utility trenches for water and sewer lines are often backfilled with sand to ensure stability and prevent settling. If there is no such sand, the settling may occur. So we just filled this with sand. Sand is used as backfill around pipes, foundations, and retaining walls to provide support and drainage. Then other example, silt and clay. So what is the use of silt? Moderate permeability used in agricultural areas where controlled drainage is essential. Ease of compaction, so used as a sub-base material for road and pavements in areas with low traffic road. Susceptibility to erosion, can't used for slope stabilization. Clay. The clay is used for brick production. So low permeability used as liners in landfills and ponds to prevent leakage and contamination. It has high plasticity used in construction of clay brick and ceramic but avoided in road subgrades due to potential volume changes. Okay, thank you.